Each chapter topic, each chapter wise we will now discuss little bit concepts and questions such that it will be helpful, because we have almost finished all the overview of the chapters once, and then you will study those portions, that concept and all the things that we have already discussed in all previous visits. Now certain things you have to do the certain derivations, because derivations are not required for particularly exam purpose, but for remembering certain formulas, certain concept. Once or twice when you are studying, you have to practice the derivation such that the related concept will be in your mind. When you are solving any problem, you can apply those concepts to solve the problem. Okay, now I will discuss chapter wise. So first we will discuss some problems from the kinematics portion, and then come to the vector and all this. So first we discuss some problems on one-dimensional kinematics. So write down the first problem. And most of the kinematics question are maybe based on vectors, because in one-dimensional kinematics no need to use the vector symbol, though in some problem if the particle changes the direction of motion, suppose it is thrown upward and after some time it is coming down, so in that case the concept of vectors has to be used to solve this problem. So first problem, write down: a particle is thrown upward with a velocity. A particle is thrown upward with a velocity 20 meter per second from the top of a tower of height 50 meter above the ground. 50 meter above the ground. How long the particle will take to reach the ground? How long the particle will take to reach the ground? Small g is given 10 meter per second square. 10 meter per second square. So in this case, the concept of vector has to be used to solve the problem, because the particle is changing the direction of velocity. Initially it is thrown up, it will reach to the top. Suppose from here it is thrown, going to the top, then again coming back and go there to the ground. So the concept of vector has to be used. That's why certain quantities you have to consider as the coordinate convention, like positive and negative, then you can solve the problem. See, suppose this one is the tower, top of the tower, and this is the ground. The stone is thrown from here. It will go to the top and then it is coming back to the ground. So at this point the stone will be momentarily at rest. Okay. So first we can consider that this is the initial position, this is the final position. Okay. Now this height is given, height is h, let us consider h. Now acceleration due to gravity and all these quantities which are vectors, we will denote them by sign. So h here is the ultimately the displacement if you measure it from point I, because this is the initial position, this is the final position. Initial to final joining by a straight line, that is called the change in position. Change in position is displacement. So what is the direction of this displacement vector? Downward. Direction of displacement vector, because we measure everything with respect to the initial point. So initial to final, so it is directed downward. Okay. Now at this point when it is thrown with a certain velocity u, so u should be in the upward direction. Direction of u is, arrow will be upward. Now in the entire path, what is the direction of acceleration? Down. So in the entire path, direction of acceleration is also down. So let us consider this is the x-axis of the coordinate system. So above x-axis, all the which are directed above x-axis, those quantities are positive. Which are directed downward to the from the x-axis, those quantities are in the negative direction of y-axis. So those quantities I will put minus sign. Okay. Now come to the equation s equal to ut plus half at square. Now s will be equal to h, but its direction is downward. So it will be minus h. U is upward, so u is positive. So I can write ut. G is again downward, means minus. So minus half gt square. Now put the given data and solve for t. H is given how much? 20. Oh, 50. Height of the tower 50. U is 20. T. G is 10. 10 by 2 means 5. So divide throughout by 5, it will be minus 10 equal to 4t minus t square. So from this you can write t square minus 4t minus 10, that is equal to 0. Okay. Now you can use Sridhar Acharya's method or any method to solve this one to find the correct answer. I can write this in this method, t square minus 40 plus 4 minus 14 equal to 0, because minus 10 can be written as 4 minus 14. So first three terms together will give you a whole square, that is 3 minus 2 whole square will be equal to root 14. Sorry, not root. On this side it will be 14. So t equal to 2 plus minus root 14. But as you can see, the correct value will be 2 plus root 14 second, because minus value if you are taking, then time will be negative, because root 14 has a value greater than 2. So if you take 2 minus root 14, then it will be a negative value which will not satisfy the natural condition. So the correct answer is 2 plus root 14 second. Okay, so whenever this type of problem is given, that it is thrown not from the ground, from a certain height, and how much time it will take to reach the ground, you have to write down this first line, how to write this line, that is important. If you simply put h equal to ut minus half gt square, you will get the wrong answer. You have to put the quantities with their respective sign, because the direction of velocity is changed. So h is downward, u is upward, g is downward. So downward, if here we consider that downward direction is negative, upward direction is positive. You may choose that the direction of acceleration is positive, so downward direction is positive, upward direction is negative. You can solve the problem, you will get the same answer. Because see, if I take minus common from both sides, it will give you the same equation. Okay, but this coordinate convention should be taken, and accordingly you have to put the variables with plus and minus with the proper sign. Otherwise this type of problem you cannot solve. Clear? So write beside this equation that we have to put the corresponding vector quantities with their respective sign. We have to put the corresponding vector quantities with their respective sign. That is very important. Remaining parts are simple calculations. Okay. Now, the second problem that we will discuss, write down. A truck is moving with a velocity, with a constant velocity v2. A truck is moving with a constant velocity v2. A high-speed car is moving with constant velocity v1 behind the truck. Constant velocity v1 behind the truck. When they are at a certain distance, the car driver applies a constant retardation. Car driver applies a constant retardation to avoid collision with the truck. Car driver applied constant retardation. Constant retardation's value is A. Constant retardation small a to avoid collision. Find the condition to avoid the collision. Find the condition to avoid the collision. Okay. Achha. Just a minute. In the question, when you write at a certain distance, write that at a certain distance x. Certain distance x. Distance is given. Means when they are at a distance x, this car driver saw the truck and applies immediately brake to produce constant retardation A. You have to find out the condition which will avoid the collision. Even if they are touched, we consider that there is a collision. And if it is smashed, definitely there is a collision. There is no collision means car will be like this. There is no touch between the car and the truck. That condition you have to find. Generally in this type of problem, 4 options are given, some greater than, some less than, some equal to, and you have to find the correct option.
V1 minus V2 whole square by 2.
X greater than.
Greater than.
Collision. Greater than or less than? Sure. अच्छा देखो देखिए करो. Which? X equal to what? No. It comes from the equation. You can write from v square equal to u square plus 2s. From that you can also consider, or from s equal to ut plus half at square, that you can also consider. Key.
So x is equal to v1 plus v2, right?
Not plus. It should be minus v1 minus v2 whole square by 2a. See, which equation you used? This one. Okay. So this is coming equal. So x should be greater than that. Then there is a gap.
Yes.
See, there are two ways to solve this problem. First one is, let us consider this is the truck and this is the car. Car is moving with V1, truck is moving with V2. So what is the initial relative velocity? Initial relative velocity U equal to V1 minus V2 from the frame of the car. Initial relative velocity, it looks like from the inertial frame, if you consider, then U will be equal to V1 minus V2. This is the initial relative velocity, right in the bracket, initial relative velocity. Okay. U is initial relative velocity. So better to write it as UR, initial relative velocity. So when there will be a touch, just touch, what will be the final relative velocity? 0, means this will touch. So the condition where just the collision occurs will be final velocity equal to final relative velocity should be 0. Clear? Now, in this way, now if I write the equation VR square equal to UR square minus 2AX. Gap between them is X and retardation is A. So putting 0 here, V1 minus V2 whole square minus 2AX. So you can write X equal to V1 minus V2 whole square by 2A. So in this case, both the vehicle will touch each other. Then when it will not touch, when X is greater than this value, X is equal to this value, then means it will touch. So if X is greater than that value, then this will not touch. So that is the condition for avoiding the collision. So the condition for avoiding the collision is X should be greater than V1 minus V2 whole square by 2A. Okay. During touch, if they touches each other, then they will cover this distance. And distance given, it should be greater than that value, then the car will not touch each other. And if it is less than that, then there will be smashing. Okay. Now, there is another method, another way to solve this problem by using the equation S equal to ut plus half at square. Let us consider that after time t, both the car will collide with each other. After time t, both the car will collide with each other. So what is the net displacement in that case? X equal to u relative into t minus half at square. So from that you can write 2x equal to 2ur t minus at square. Then we can write at square minus 2ur into t plus 2x equal to 0. Now if collision occurs, then this t should be real number, real, and if collision does not occur, means t should be complex. So roots of this equation complex. T real means the phenomena will occur. T not real means complex means or imaginary, that means the phenomena will not occur. So what is the condition for complex root? Discriminant less than 0. Discriminant less than 0 from this equation. This is b. So b square is 4ur square minus 4ac. 4 into a into 2x means 8ax less than 0. So from this we can write 8ax greater than 4ur square. So x greater than, a particle is moving from rest with constant acceleration. A particle is moving from rest with constant acceleration for certain time. Constant acceleration small a. Constant acceleration small a for certain time. Then with constant velocity for certain time, and then with constant retardation small a. Then with constant retardation small a means acceleration and retardation have same value. Constant retardation small a until comes to rest. Until comes to rest. Okay. The total time for the journey, is 25 seconds. Total distance traveled or displacement, it is moving in the same direction, total displacement equal to equal to 100 meter and acceleration has a magnitude (1 meter per second square). Acceleration has a magnitude 1 meter per second square, means retardation also have the same magnitude. Then calculate the time during which the car moves with constant velocity. During which the car moves with constant velocity. Acha, first try to tell me which procedure should be used to solve this problem. Which equation or any other mechanism? See, you can solve the problem by using the equations of kinematics. But in this case, that will lead you to a very long calculation. There is another method in the kinematics, that is the graphical method to analyze the equation. Because you have to study many graphs in kinematics, that is displacement time graph and velocity time graph. By using velocity time graph, you can solve the problem easily. Okay, first we have to consider in this way. That this is the velocity axis, this is the time axis. Now, first try to represent the motion in the graph. From rest, the velocity is increasing because of the constant acceleration. So it will be a straight line inclined to the time axis. Then for certain time it moves with constant velocity. Constant velocity means this line will be now parallel to the time axis. Okay. Then again with constant retardation. and see the graph, this one and this one will produce an isosceles trapezium because acceleration and retardation's values are same. So both are equal and they have same angle on this side and this side. They will produce an isosceles trapezium. Clear? Now, here I will derive a general formula for you such that for this type of a problem, you can remember the formula and put the values directly. Okay. Because if I solve this problem particularly by using the numerical values, then you will not have this mathematical formula to remember, and then at every time you have to solve from the beginning. So I will derive a general formula for you. You will remember that formula and apply if this same situation occurs. Now let us consider, I will split these things into parts. See, now I will do certain arguments. First, I consider that the entire time that is given for the motion is small t. I consider entire time given for the motion is small t, suppose. Okay? Now, I consider that the time taken for maintaining uniform velocity is this much, and that is considered as capital T. I consider as capital T. Entire time is considered as small t. The time for uniform velocity is considered as capital T. Then just tell me, if uniform velocity takes time capital T, then how much time is left for acceleration and retardation? Small t minus capital T. And that should be equally shared between acceleration and retardation because they have the same magnitude. So I can consider that time taken for accelerated portion is small t minus capital T divided by 2. For this one, it is also small t minus capital T divided by 2. So I write the time for 3 parts individually. First one, small t minus capital T by 2, then capital T, then small t minus capital T by 2 again. Now, it starts with velocity 0, that is the initial velocity. It achieves the final velocity at this point. What is its value? Let us consider v. After acceleration, at the end of acceleration, it goes to a final velocity v, maintain that velocity for time t, and then comes to rest due to retardation. Now this one, up to this point, the velocity will be v, and it is reached due to the acceleration. So I can write v equal to u plus at for this part. So using the equation, I can write v equal to final velocity. Initial velocity is what? 0. A is acceleration. T is small t minus capital T by 2. That is the acceleration taken for, that is the time taken for acceleration. So that is small t minus capital T by 2. This is my first equation that I derive. Now, except the total time, another thing is given in the problem, that is the total displacement. Because area of velocity time graph represents displacement. So simply calculate the area of this trapezium, that will be equal to displacement. Okay, so what is the area of trapezium? Half into sum of the parallel sides into perpendicular distance between the parallel sides. You have to remember that. Now, it is half. Now this parallel side, this is another parallel side. What is their sum? Small t plus capital T. This side is small t. This is another parallel side, that is capital T. So their sum. And tell me, what is the distance between the parallel sides? This height, that is V. So put the value of V here. Sum of the parallel side means small t plus capital T, and distance between the parallel sides means perpendicular distance is that final velocity that is achieved, V. Now, can I write here 4s by A? 4s by A. That will become t square minus t square. T plus t into t minus t is a plus b into a minus b. Okay. Then I have to find the value of capital T. It will be t square minus 4s by a, entire thing under root. This is the final formula which you will remember.
Can you explain again how did we get the value of V?
Here velocity is at this point, the velocity reaches to V. So this part is only constant acceleration. So we have to use the equation V equal to u plus at. V is the final velocity, u is 0, a is acceleration, time taken for this part is, so I put it. So if you use this graph, then you can easily deduce the equation and solve the problem. And whenever you will solve the problem, you may remember this equation, final equation, and directly put the value. No chance to deduce it in the hall. Now see, all the values under the root are given. Check. Total time taken 25. Total displacement given 100, and acceleration given 1 meter per second square. Put the result and you will get capital T equal to 15 seconds. Actually, before giving the problem, I am calculating that whether it is coming in a perfect square or not. So small t equal to 25, its square will be 625. S is 100, A is 1. So 4s by A is 400. So 625 minus 400 means 225. Root 225 means 15. So answer will be 15 second. So among 25 second, between 25 second, 15 second time, the car is moving with constant velocity. Rest of the times 5 seconds is used for acceleration, another 5 seconds is used for retardation. That is the problem. Whenever this type of problem is given, that sometimes acceleration, sometimes retardation, sometimes uniform velocity, always try to, in a particular problem, if acceleration, retardation, constant velocity, these are mixed, always try to solve it from the graph. Don't try to use the equation, because there will be too many equations and as a result you will be puzzled. Draw the graph and from that analyze the motion. It will be much more simpler to draw, conclude the final result from the graph. That is for acceleration and retardation. If there is no uniform velocity part.
Sir, if we minus that part,
Then we can. So always graphical method is much useful in that case. Okay. So whenever you are preparing for final touch of the kinematics topic, this velocity time graphs are very important to solve the problems, because it will give you a very easy calculation for many of the problems, where those problems, if you try those problems using the direct formula, it will lead you to a long calculation. So read these portions carefully such that you can tackle and solve the problem by using the graph. Because see, this general derivation, it takes only 4 lines and the concept of the graph. But if you try to derive this general form by using the equation, it will be very difficult. 4 to 6 equation will come, and then you have to simplify all those equations to arrive at this result. But here we arrive at the result almost in 4 mathematical steps. So general equation is this much easy, so deriving from the graph. So then you can think of that in a particular problem how easy it will be, rather than using the equations. Okay. Now, there is another problem related to this type of motions, but you can skip that problem also. The formula for the nth second formula you cannot directly skip. Suppose, but some problems are there that in the 7th second the particle crosses this distance, in the 11th second particle crosses that distance. So what is initial velocity and what is the acceleration? If only one situation in this problem may come, that value of u and a are given, and there are 4 sets of values given, you have to find the correct option. Only thing this, but not much more difficult problem on this nth second equation you have to practice. Okay, so I will give you just a simple problem which is based on this nth second formula. S nth equal to u plus half a into 2n minus 1. So write down. Then it will be much more difficult. Then you have to separately calculate all the things. T1 plus T2 plus T3, separate time should be taken. Yes. Now, a particle moving with constant acceleration crosses a distance. A particle moving with constant acceleration crosses a distance (30 meter) in 7th second of the motion. In 7th second of the motion. And a distance (50 meter) in 11th second of the motion, and a distance 11th meter 50 meter and a distance 50 meter in 11th second of the motion. What will be the acceleration and initial velocity of the particle. Acceleration and initial velocity of the particle. These two you have to find out, because there are many problems in which 4 pair of values are given. You have to choose the correct option. See, this formula we have to use. S nth equal to u plus half a into 2n minus 1, distance travelled in the nth second of the motion. First it is given that 30 in the 7th second distance covered is 30. So first equation we can write here, 30 equal to u plus half a into 2n minus 1. What is 2n minus 1? 14 minus 1, that is 13. 7, n is 7 in the first case, given 7th second. So n will be 7. So 7 into 2, 14, 14 minus 1, 13. So it will become 13 by 2a. So this is your first equation. The second equation, it is given 50 meter is crossed. So it is u plus, now n is given 11th. So 11 into 2, 22 minus 1, that is 21. So it will be 21 by 2a. Okay. Now first subtract equation 2 minus 1. Do this. 2 minus 1. 2 minus 1 will cancel u. We are doing simultaneous solve now. So 50 minus 30, that is 20. U minus u will cancel. You will get 21 minus 13 into a by 2. So 21 minus 13 means 8. So it is coming 20 equal to 8 by 2a. 4. So a will be 5 meter per second square. And just now put this value 5 in any of the equation. So I put it in equation 1. So 30 equal to u plus 13 by 2 into 5. So this will be u equal to 30 minus 65 by 2. So it will be u equal to 60 minus 65. So minus 5 by 2 meter per second. Means 2.5 minus 2.5 meter per second. So this is the value of the initial velocity. So initial velocity and acceleration are oppositely directed in this problem. Okay. So this is a simple calculation, because after preparing the equation 1 and 2, rest of the thing is simply simultaneous equation solving, nothing else. So suppose velocity vector of a particle is given by x I cap plus y square j cap. Velocity vector of a particle is given by x I cap plus y square j cap. Then find the equation of trajectory. Then find the equation of trajectory of the particle if it starts from origin. If it starts from origin. Means at x equal to 0, y equal to 0, and now it moves in this fashion. A particle moves in a xy plane whose velocity is given by x I cap plus y square j cap. Find the equation of trajectory of the particle. Like in projectile motion, we find the equation of trajectory. So similarly here we want to find the equation of trajectory. See, for calculation of equation of trajectory in case of a projectile motion, what we have done? we have an equation x equal to u cos theta into t, y equal to u sin theta into t minus half gt square. We eliminate t to get the equation y equal to tan theta into x minus gx square by 2u square cos square theta. Here we have to eliminate time similarly, but it looks like there is no time involved in this equation. Then how can we eliminate time? Okay, now can I write this v as vx I cap plus vy j cap, that is coming x I cap plus y square j cap, x I cap plus y square j cap. Right? Now, then Vx will be equal to x. Now what is Vx? dx dt. Vx means dx dt. So we can simply write dx dt equal to x by comparing the coefficient of I cap. Similarly, Vy means dy dt. So we can write dy dt, that is equal to y square. Okay, so we can write dx dt divided by dy dt, that will give you x by y square, x by y square. So you can write dx by dy equal to x by y square. See, time is eliminated. Okay, now you can write it is dx by x equal to dy by y, sorry, dy by y square, dy by y square, and then simply integrate. So it will be log x equal to minus 1 by y plus some constant c. So better to write this constant in this format, log c, because I can write the constant in any form. So I write the constant as log c. Okay, log c can be written as constant, or instead of that I write log c. Now what is the advantage in that? I can write it is 1 by y equal to log c minus log x. So 1 by y equal to log c by x. So what is y? One by log c by x. That is the equation of trajectory. Y equal to 1 by log c by x. That is the equation of trajectory. Done? Now, is it clear? So don't think that t can be eliminated from the algebraic format. It can be in a differentiation, but it can be eliminated. So equation of trajectory finding means you have to eliminate the parameter time, which is not geometrical parameter. X and y are geometrical coordinates. T is not a geometrical value. Time. So you have to eliminate time to find the equation of trajectory. So write it. Equation of trajectory means the path, the geometric path. Equation of trajectory means these short notes, the points that conceptual points that I am saying. So incorporate this in your notes by slight small heading or slight highlighted marks. Notes will incorporate in the your notes. In that case, when you revise it for the exam, you can grasp those concepts easily and remember those particular points. Equation of trajectory means a geometric equation relating the geometrical variables x and y. Geometrical variables x and y. It should be irrespective of time. It should be irrespective of time. Means time has to be eliminated from the equation to find equation of trajectory. It is a relation between x and y coordinate, which are geometrical variable. So for that, if there is time involved, you have to eliminate that time using the geometrical quantities. Okay. Now, so I will give you one more equation. In the problem it is said that a particle, write down, a particle moves in the xy plane, a particle moves in the xy plane following the equation r equal to t square minus 1 I cap plus 2t j cap. Plus 2t j cap. Okay. Where r is the position vector of the particle. R is the position vector of the particle. Find the equation of trajectory. Find the equation of trajectory. Previously, from a differential form, you have to find the equation of trajectory. Now it is from a algebraic pattern, you have to find out the equation of trajectory. Similarly, by eliminating t, we require an equation between x and y. স্পেশাল ট্রেনটা কালকে রাত্রে দিয়েছে না, ওই এত প্যাসেঞ্জার হয়ে যাচ্ছে, সব ট্রেনে টিকিট নেই তো, এই যে দেওয়ালির জন্য ফেরার, তো দেওয়ালি ভাইফোঁটাদের ফেরার এত প্যাসেঞ্জার হয়েছে, কারণ শিলচরের ওদিকে একটা বাঙালিদের প্রচুর ইয়ে রয়েছে তো আগরতলার দিকে, তো সেই কারণের জন্য এত হ্যাঁ একটা স্পেশাল ট্রেন অ্যানাউন্স করেছে। স্পেশাল ট্রেনটাতে আজকে সকালে উঠে খুলে দেখি 80টা টিকিট রয়েছে 3টা এসিতে সব আর ইনফ্যাক্ট আজকে তো এইটা সেশনের পরে তো আর তো কোনো কিছু নেইও, শুধু হ্যাঁ সন্ধে আমার টিকিটটা তো কালকে ছিল সরাইঘাটেরটা ক্যান্সেল করলাম, মানে এটা কেটে হ্যাঁ, আর এটা সন্ধেবেলা 7:30 গুয়াহাটি থেকে, কালকে দুপুরবেলা 12টা 12:30 এটা ডানকুনি পৌঁছে দেবে। ডানকুনি থেকে তো 4-5টা স্টেশন হাওড়া, না হলে আমি তুমি দক্ষিণেশ্বর দিয়ে মেট্রো ধরে নেবো। আর সরাইঘাটটা তো কালকে ছাড়বেই 12:20, ততক্ষণে আমি ওদিকে পৌঁছে যাব। পৌঁছে সরাইঘাট ভোরবেলা নিয়ে গিয়ে 5:30 নামাবে মঙ্গলবার, তো সেখানে আমি কালকে দুপুরেই বাড়ি পৌঁছে যাব। আমাকে দমন স্যার আসার পরের দিনই বলেছে যে স্যার সানডেতে কিন্তু ওই শুধু ওইটার পরে, ইনফ্যাক্ট প্রথম তো গত সপ্তাহে যেটা হয়েছিল না, ভেবেছিলাম যে সানডে ক্লাসই নিই, তারপরে বললো যে না, তাহলে যদি সানডেই হয় তাহলে তো খুব সুন্দর, আমি তো আগেই বেরোতে পারি একদিন আগে। কিন্তু তখন চেক করেছি আমি তখন থেকেই, কিন্তু কোনো ট্রেন দেখাচ্ছে, কালকে রাত্রে দিয়ে দিয়েছি। See how to eliminate. Generally position vector is written as xi cap plus y j cap. So position vector R, write this one, xi cap plus y j cap, that is equal to t square minus 1 I cap plus 2t j cap. Now compare the coefficient of I cap and j cap. Then x will be equal to t square minus 1 and y equal to 2t. So from these two equation, eliminate t. So from this we can write t equal to y by 2 and substitute it here in place of t. You will get the equation of trajectory. This one is much simpler. T equal to y by 2, then substitute the value of t in that equation, first equation, as t square. So it will be x equal to y square by 4 minus 1. So we can simplify this one by saying, writing y square equal to 4x plus 4. This is the equation of parabola. First power in x, second power in y. So whenever there is a equation of two variable containing first power of one variable and second power of other variable, it will lead you to a parabola. Okay, but the previous equation is not a simple curve, it is a complicated curve. So whenever equation of trajectory will be there, and in this case of I cap j cap format given, write down the position vector or velocity vector, and from that try to eliminate t. You will get the equation of trajectory. Okay, now next problem. A particle is thrown with speed. A particle is thrown with speed 10 meter per second at an angle (45° with horizontal. Find the radius of curvature. Find the radius of curvature of its path. Of its path near the topmost point. Radius of curvature of its path near the topmost point. Acceleration due to gravity you can consider to be 10 meter per second square. 10 meter per second square. Square 45 by G. আনলে কি করে এটা?
আপনি করেছিলেন।
ও বুঝছিলাম। দেখি কজনের মনে আছে। এখন পাইনাপেল পাওয়া যায়? পাইনাপেল
আমার ওইদিকে তো নাই, শেষ হয়েছে।
শেষ না?
এইদিকে সাপ্লাই করতে পারে, আমি তো জানি না।
কারণ যাতায়াতের
ওইদিকে যদি ডাইরেক্ট এইদিকে কোম্পানিতে দেয় না।
ও কোন সময়টা পাওয়া যায়? গরমের সময়টা?
গরম
শীতের তো খুব একটা।
জুলাই আগস্ট।
এখন কি পাওয়া যায় এখানে?
তো আমার
দেখবো যাওয়ার সময় যদি পাওয়া যায়।
এদিকে থাকতে পারে সাপ্লাই।
Now I understand why you try to break that grill yesterday. This cushion is containing a tiger. He's like a tiger.
रेंज का ऐसा निकलना चाहिए, इसका हाफ निकलना चाहिए।
We have discussed this one in the class. It will be u square cos square theta by g. Theta by g, that is the radius of curvature. That is not the half of the range. How many of you remember how to calculate radius of curvature? We have discussed this in the class. When we are discussing projectile, radius of curvature. When we discuss projectile in the class, we discuss that. Because radius of curvature means near the topmost point, you can consider a small segment. You can consider it is a part of a circle.
Okay.
Then at that point velocity is u cos theta. So this is V, and you can consider here acceleration is
G.
so G should provide centripetal acceleration.
Okay.
So R equal to V square by G, that is U square cos square theta by G, that is radius of curvature. Because near the topmost point, if you consider a small part, then it may be considered as a arc length of a circle, but small part it should be. That's why at different point the curvature will change, because if it is complete circle, at different point radius of curvature will remain same, but it's a parabola, we are approximating it by using circle.
Not
Oh, you are calculating through this. Okay.
this one.
This formula, correct. Okay, this one is U is given. No, U is what? U is 10, initial velocity. At the topmost point, for that you use this one.
Sir, formula.
U square cos square theta by G, that is the radius of curvature. See, so this is the projectile motion. Now we consider that it is thrown with velocity u at an angle theta. Then near the topmost point, what is the velocity? V we consider, that is u cos theta. Okay. Then what do we mean by radius of curvature? For a circle, if we consider, at each point radius of curvature remain same. But for a parabola, at every point radius of curvature will be different. That's why it is not a circle. Now near this topmost point we consider a small segment. Now can you tell me, between those two red marks, the length, whether it is a length of a parabola, or even I can consider that is a length of a arc of a circle, portion of the arc of a circle. So no one can challenge. So at that point consider a circle. That circle center radius is called the radius of curvature. While you are differentiating anything, suppose a curved line, you are differentiating, you consider that small portion of the curve is almost like a straight line. Now we are doing a better approximation, that small portion of the curve is considered as a part of a circle. So its center is termed as the radius of curvature. It is not related to the range. Radius of curvature. Now what is the acceleration at that point? It is directed downward and it is g, acceleration due to gravity. This velocity is perpendicular to the acceleration due to gravity at that point, because acceleration due to gravity is towards center of that circle. So it is behaving as centripetal acceleration. So what is the magnitude of centripetal acceleration? We know g, then it is equal to v square by r. So v is what? U cos theta. So write u square cos square theta by r. So from that you will get the formula of radius of curvature, that is u square cos square theta by g. Just put u is given 10, angle is given 40, 45. So cos 45 is 1 by root 2. So it will be 10 square. Next problem is Next problem we will discuss mainly from the motion of a particle, in a circle. First you consider that some conceptual question can come from that. Okay, particle is moving along a circle. Suppose its velocity vector at this point is like this, v, and at this point its velocity vector is this is the velocity vector at this point. Particle is moving with uniform speed. So write down the velocity vector of a particle, velocity vectors of a particle at two different positions are shown in the diagram. If the particle is moving with uniform speed, if the particle is moving with uniform speed, then uniform speed v, if the particle is moving with uniform speed v, then find the magnitude of change in velocity. Find the magnitude of change in velocity of the particle. Magnitude of change in velocity of the particle. What is the magnitude of change in velocity? What? Root 2 v. Magnitude of change in velocity is root 2 v. How it comes? See, first we consider this is a velocity vector v1. Next we consider this is the final velocity vector at this point. It is denoted as v2. Okay. So I will join them I will draw them as co-initial. I want to draw them as co-initial vectors. Means this is v2. This is v1. Now what I want to find? I want to find first the change in velocity, that is v2 minus v1. Okay, I want to find this one, v2 minus v1. So whenever you have to subtract the vector, what we have to do? We have to reverse the vector and join it. Means subtraction means we can always realize that subtraction is adding the negative vectors. So first you consider negative of v1. This should be oppositely directed to v1. This is denoted as minus v1. Okay. Then resultant of these two we have to calculate. Clear? Resultant of these two we have to calculate. First we will draw them as if V1 is inverted. So we have to calculate the change in velocity. Change in velocity means final velocity minus initial. So V2 minus V1. So V2 minus V1, I can think of that minus V1 means addition of minus V1 with V2. So we have to subtract V1 from V2. We will consider that we have to add minus V1 with V2. So V1 is inverted. Minus V1. Now this one will represent the relative velocity. That is the change in velocity. Change in velocity means relative velocity. So we write it VR. Okay. Now we have to find its magnitude only. So what is magnitude? If this is V1, this has also V1 magnitude. So this is the hypotenuse of this triangle. So VR magnitude will be simply root 2 times V. From the Pythagoras theorem you can find. This is V, this is V. Magnitudes are same. So this hypotenuse will become root 2V. Okay. So if you remember the diagram, vector diagram and all this, you can solve this problem easily. Otherwise, V2 minus V1 you can write and then find the angle between V2 and V1 and directly use the resultant or subtractant formula. Subtractant formula means root over of a square plus b square minus 2ab cos theta. You can already apply that, and that theta will become 90 degrees. So cos 90 will be 0. So it will be v square plus v square. So from that you can also calculate. Okay, either proceed through this graphical method, or you can consider that what is the angle between V2 and V1. If I draw V1 here, the angle between them is 90 degree. You can apply the formula for subtractant, that is VR will be equal to root over of V2 square plus V1 square minus 2 V1 V2 cos theta. Resultant and subtractant can be calculated from the same formula by using the angles. For resultant I write this one plus, for subtractant I will write this one minus. So it will be v square plus v square. Cos 90 means last term will be 0. So it will be root 2v. So any way you can find. But whenever you are practicing, don't only practice from the formula, also try to practice from the normal graphical method, because it will give you too much insight to solve the problem and how to draw the vector such that you can apply that concept in any other problem when you are solving that problem. Okay, so first technique is much more conceptual. So drawing it individually and then constructing, then you have a good grasp over the entire thing. Done. Now, this is the from the kinematics of circular motion, and you can consider it is as simple as a calculation of the vector algebra. Now, when we move on to the dynamics problem, first remember the major portion of the dynamics problem is depending on the drawing of a free body diagram. Free body diagram, normally it is not given in many textbook. Free body diagram is not highlighted that much. There is no topic called free body diagram in any textbook. You will find some free body diagram technique in the competitive exam books. Free body diagram you have to practice. From different problems you have to draw the free body diagram. Remember certain things in the free body diagram. If you are drawing a free body diagram as predicted by Newton, for solving problems or Newtonian mechanics style, then you have to draw only the real forces on a particle in a free body diagram. Only the real forces. Pseudo forces cannot be drawn in free body diagram. Okay. Free body diagram, that means, can only be drawn from the inertial frame of reference. So first you consider that observer is in a inertial frame of reference. Then he can say that all the forces are real and I can draw the free body diagram. Now suppose there is a complicated structure in which 3 to 4 bodies are joined. So you can separate each mass separately from the complicated structure, and you have to draw all the forces that is acting on this any particular mass and given by some other object or other agent. Okay, suppose I am taking this marker, is this one is a mass, and suppose this one is another mass, they are connected. This mass can apply a force on this, but when we write the free body diagram on this one, I cannot consider that particular force which it can give on any other. The force the others can give on this, I will incorporate it in the free body diagram of this marker only. Similarly, this phone can apply force on this marker, but I will not consider that particular force when we discuss the free body diagram of this mobile. So whenever, remember, free body diagram, a particular mass is drawn, so only the forces that is given on this mass by the other masses and other objects, those can be only drawn in a free body diagram. If you draw the force of this mass given on other, then it is wrong. Clear? Because Newton's law clearly states that only external force can produce acceleration. Internal forces cannot do. So if I consider that this mass exerts force on itself, then this is an internal force, and if you write it on the free body diagram, it is wrong. Clear? Now, when you draw this from a complicated structure, separate the masses, then you have to remember that all the connection with that particular mass can apply contact force, and even there are certain cases there are no connection but some field forces, means non-contact forces should be there. So you have to draw all the forces. If any one of the external force you miss in the free body diagram, then entire calculation will be wrong. Clear? So this is a caution when you draw the free body diagram. Now, in certain cases, we consider non-inertial frame for the simplicity to solve the problem. In those cases, you can draw pseudo forces in the free body diagram. But remember, you will consider non-inertial frame. In those cases, you can draw pseudo forces in the free body diagram. Okay, and solve the problem by considering that there is no motion, because the acceleration is an effect actually which is produced by the cause, that is force. Now in the non-inertial frame, observer considers acceleration as if it is cause. That means he is treating it as pseudo force. So there will be no effect produced by all this, because real forces and pseudo forces will balance. So we consider that the body in the non-inertial frame is at rest and solve the problem. Any particular dynamics problem can be solved by using inertial frame and non-inertial frame both. That does not mean that if I consider inertial frame, you cannot consider non-inertial frame to solve the same problem. You can solve, but only you have to remember all the concepts that free body. When we consider inertial frame, no pseudo force will come, and it may be a problem of acceleration, but the non-inertial frame, you will consider pseudo force, and it is converted to a problem of equilibrium or rest. Draw the free body diagram, find the physical quantity that is asked in the question. If you consider if you find some value of a certain physical quantity from the non-inertial, by considering non-inertial frame, and I consider inertial frame to find the same quantity, both of us will have the same value, because the value of any physical quantity is independent of the frame chosen for the problem solving. It is not depending on the frame, because suppose we are calculating the values of the acceleration or tension or velocity, it cannot depend on the reference frame. It is a physical quantity, so its value will remain same. Value should remain same. Physical quantity's value should remain same. Okay. Now, there are certain problems of the equilibrium under the action of three forces. Under the action of three forces, there are certain problems of equilibrium. Means these forces, suppose like this, F1, F2, F3. Now suppose three forces are there. The angle opposite to F1 is considered as alpha, angle opposite to F2 is considered as beta, angle opposite to F3 is considered as gamma. Okay. Then it is said that these three forces are acting on a particle, and under the action of this particle, if the particle is in equilibrium, means it can be either at rest or moving with uniform velocity, because both are the conditions of equilibrium. First one is called static equilibrium, second one is called dynamic equilibrium, but both are equilibrium. Then since they are in equilibrium, means three forces sum should be 0. So we can immediately write F1 plus F2 plus F3, that should be 0, null vector. Now if this can be 0, some of the three vectors can be 0, I can represent those vectors by the sides of a triangle where all sides are taken in same order. All sides are taken in same order, means it starts from a point and after coming it will converge to that point, so the sum of the force will be 0. So immediately I can write this one by a triangle. This one F2, F1, F2, F3. Check, all are taken in same order, and in this situation you will find that if this is F1, this angle will be alpha. You can consider this F2's opposite angle is considered as beta, F3's opposite angle can be considered as gamma, and you can immediately write for both of the shapes F1 by sine alpha equal to F2 by sine beta sine gamma, called the Lami's theorem, or in trigonometry it is generally termed as sine rule. Cosine rule you have already studied, that is the vector addition formula, that is actually the cosine rule for the triangle, it is the sine rule for the triangle. Okay. Now, there are certain questions and problems coming from Newton's laws of motion. One such problem is that very common conceptual problem. Which law of Newton is valid in non-inertial frame? Which law of Newton is valid in non-inertial frame? Suppose options are given: first law, second law, third law, and all of this. In non-inertial frame, which of the Newton's law is valid? Options are first law, second law, third law, and all of this. Which one is the correct option? A, B, and C, A, B, C, D. First law is valid in non-inertial frame, second law is valid in non-inertial frame, third law is valid in non-inertial frame, or all the laws are also valid in non-inertial frame. So first write down the question. Which of the Newton's laws are valid in non-inertial frame? Option A, only first law. Option B, only second law. Option C, only third law. Option D, all of the laws, all three laws. What is the correct answer?
Third law, sir. Third law.
What you will do if this question comes in NEET exam? This is a practical situation. This situation may come in the exam. Suppose you can't decide which option is correct in this situation, then what you will do? See, correct option is not there. None of the Newton's laws are valid in non-inertial frame. Newton's laws are only valid in inertial frame of reference. Okay. So whenever this question comes, this type of question, if comes, just attempt that question. You will give the bonus mark. Since this question is wrong, the entire mark will be given. But for that you have to attempt the question. But again, there is two possibilities like quantum behavior, like dual behavior. If you consider the question is wrong and you attempt, and suppose the question is not wrong, it will be negative mark. And if you are so confident that this question is wrong, then only attempt this. Otherwise, don't try to make an attempt based on your confidence that it is wrong. Okay, if you are confident enough, then only attempt, because without attempt you will not the grace mark. With the attempt you will got the grace mark. But now I think this situation is changed. If there is wrong question, everyone attempting or non-attempting will get the grace mark. So if this type of question comes that it seems that none of the options, Newton's law, so don't try to put that Newton's second law is valid, first law is valid, third law. None of the Newton's laws are actually valid in non-inertial frame of reference, because all this Newton's law considered in inertial frame of reference. For applying Newton's law, second law, or in non-inertial frame, we have to modify the law by introducing pseudo force. Once pseudo force is introduced, then you can write Newton's second law in non-inertial frame. And no question of validity of the first law, because first law discards at the beginning. Non-inertial frame, when you consider, first law is not there. It is the non-inertial frame. First law comes with inertial frame. Clear? And third law is a special characteristics of action and reaction. You will not find any reaction for the pseudo force. So no question of validity of the third law. Okay? Now, so these are certain conceptual questions which will come, and without any calculation you can write the answer, but remember your concept should be very clear, otherwise it is difficult to answer. Next, the pulley problem that we have already discussed. If we consider that the pulley and the wheel have friction, we normally consider the pulley wheel is there and a rope is passing over the pulley wheel. There is no friction between this rope and the pulley wheel. If there is a friction, then what is the problem? So I will write 4 options. So first write down the question. In a single fixed pulley problem, if the rope and the pulley wheel, if there is friction between rope and pulley wheel, okay, then option A, so write down option A. Tension will be different in both sides. Of the rope. Okay. Option B, acceleration on the both sides of the rope are different, means acceleration of the masses on both sides of the rope are different. Option C, টেনশন ডিফারেন্ট হচ্ছে কিন্তু স্ট্রিংয়ের লেন্থটা কনস্ট্যান্ট, সেখানে অ্যাক্সেলারেশনটা সেম। স্ট্রিংটা তো ইনএক্সটেন্সিবল নয়, নর্মালি যেটা পুলি প্রবলেম তাদের স্ট্রিং তো ইনএক্সটেন্সিবল, তাহলে অ্যাক্সেলারেশন ডিফারেন্ট হতে পারে না। মানে এটা ঘুরবে স্লোলি, টেনশনটা আলাদা হয়ে যাবে। অপশন A and C correct. Option A correct, option C correct. Means if there is a friction, then tension on both sides will be different. But that does not mean acceleration is different, because string is inextensible. So until the string is extensible, acceleration will not be different. So acceleration will remain same, but tensions will differ because of the presence of friction. Okay, so option A correct, option C correct. Remember, only if there is extensible string, then only acceleration will change on both sides. Whatever be the other situation, pulleys may have mass, strings may have mass, anything. But if it is said that strings are inextensible, always write acceleration to be same. Okay, so in this case, the normal pulley problem, only there is friction, so inextensible string we consider, and as a result acceleration will remain same. But since there is a friction, the tension on the two sides will change. But don't think that tension force changes means acceleration will change, because acceleration is not produced by tension alone. There is a role of mg also in producing the acceleration, and in this case, since friction is present, friction is also there. Okay, so combination of all the external forces produces acceleration. That does not mean if tension changes, acceleration will change. For the acceleration change, you have to consider the physical situation, that the string is inextensible or not in this single fixed pulley problem. Clear? So these are the certain cases, no need to calculate anything, but you have the concept for answering this. So meanwhile, for certain months, you can consider, as Varun sir already told you, that for the physics, you may focus too much now on the physics concept, not on the extensive practice of the numericals, because there is no bar on the numericals which can come in the exam. There is no bar practically. Anything can be considered as a numerical problem. So try to first get a good concept over the theory, the conceptual portion, those questions that I discussed last and from the mechanics portion. Then once you have completed all the your theory, then you try to solve the problems. Okay, because otherwise it happens that if you start solving the problems of any chapter, and then suppose you try first problem, it cannot be done by you. Try second problem, it cannot be done by you. Third problem, it cannot be done by you. Then in this way you will be disheartened, and you will say that no problem I can solve. I cannot solve anything, so better to leave this subject. Okay, so it is not the problem with all of you, I know, but some students may get disheartened in this method. So that's why for them I said that first try to grasp over put a command on the theory portion, then concept will build slowly, then try to solve the problem. Otherwise, if you try to solve the problem for very beginning day without completing the concept of the chapter, you can't solve the problem. Now I think you have already realized that among these three subjects that you have to give the exam in the NEET, physics is most difficult, because after reading everything I can supply all the equations in the note. I consider that your memory is so strong that you can remember all the 100% all equations. Even after all this, you cannot solve the problem, because you have to apply those equations to solve the particular problems. Because The all equations, knowing all the equation is not sufficient. You have to know where it has to be used, where to use what. Suppose you are using a different equation to solve a different problem, you cannot solve. So that's why it is difficult. So since the subject is difficult, there are certain, you can split your preparation into parts. That theory portion I will complete, then I will solve the conceptual question which do not require that much of calculation, and after that I will try for those problems which require bit of calculation. Clear? And try to first complete those chapters which are not so analytical. Means modern physics portion. These are very easy. Just formula based, you know the form. If you know the formula and direct question comes, that directly put the new numbers in the formula and solve the problem. This type of question comes in the modern physics. So modern physics part is very easy. Another easy part is heat. Another easy part. The optics portion, geometrical optics portions, those are all also straightforward questions will come from this. In the mechanics portion, in electricity and magnetism portion, there may be some twisted question. Mainly in case of mechanics portion, there may be twisted question. Okay, mechanics portion, electrodynamics portion, all these are too much analytical. Many numericals, many formulas and all these things. So first, try to finish those portions of the modern physics which I discuss in this visit, because modern physics are very easy. Okay, and after that, one by one, try to solve the different parts. First concept portion, theory portion complete, then try for the numericals. Clear? Okay, and even if someday you start solving numericals, if you start 1, 2, you cannot solve, don't try to waste your time by putting more effort on those numericals at that time. Because if you are in class 11, then I will suggest that until that numerical is solved, try it. But since you have not that much of time, so just forget about that numerical, prepare the other theories and other portions that will help you in the exam. Clear? So this is the method to tackle physics. Otherwise, it is very difficult. Okay.